Hello everyone. In this video, let's discuss how to write a program to find palindrome linked list. Given the head of a singly linked list, return true if it is a palindrome or false otherwise. So here they have given list of 4 elements. I need to check whether this given linked list is a palindrome or not. So here 1, 2, 2, 1, it is a palindrome, so it has written true. Another example I have given here is 1, 2. So here it is not a palindrome, so we have written it as false. Now let's discuss the logic in detail. So here I have taken a linked list which consists of 5 elements. So to find whether it is a palindrome or not, we have to do 3 different things. First one is find the middle element of the list. And the second step is reverse the second half of the list. After that, compare both the lists. This is the logic of finding the linked list, whether it is a palindrome or not. Okay, so first let's go for finding the middle element of the linked list. Let's discuss the logic of finding the middle element of a linked list. Here I have taken a linked list of size 5. The logic is very simple. Here we have to take 2 objects. One is slow and another one is fast. Okay, we have to start iterating slow by 1 step and fast by 2 steps. Whenever fast reaches the last node of the linked list, wherever slow is pointing, that is a middle element of the linked list. To know whether fast reaches the last node or not, we have to write the condition. That is, fast not equal to null, and along with this we have to check whether the next node should not be equal to null. So fast dot next not equal to null. Current node and the next node both should not be equal to null. Reason is we are moving fast by 2 steps and slow by 1 steps. That is why we are checking fast not equal to null and fast dot next also not equal to null. If the condition is true, I have to move slow by 1 step and fast by 2 steps. Then after coming out of the loop, what should I do? I have to return slow. Wherever slow is pointing, that is a middle element of my linked list. Let's check. Well, fast not equal to null, yes, fast is not equal to null, that is 1000. Fast dot next is not equal to null, yes, that is 2000. The condition is true. If the condition is true, I'll go inside the loop. Slow has to be moved by 1 step, so it will be pointed to the relation called 2000. Fast has to move by 2 steps, so first step 2000 and the second step 3000. Now check the loop. Fast not equal to null, yes. Fast dot next is also not equal to null, yes. Condition becomes true, so I have to move slow by 1 step. So slow will be pointing to 3000, fast will be pointing to 5000. First step and second step. Now check the loop again. Fast not equal to null, yes. Current node is not equal to null. Fast dot next to not equal to null, condition becomes false because next node is null. So I'll come out of the loop and I'll be returning wherever slow is pointing. Slow is pointing to the relation called 3000. So this is the middle element of my linked list. So now let us try to write the logic for finding the middle element of a linked list. For that we have to check one condition, that if head is equal to null or head dot next is equal to null, we have to return head, which is true. Sorry. Now I am going to find the middle element. So to find the middle element, I have to take 2 objects, slow and fast. Both are going to point to the first node, that is head. So I have to take a loop now. While fast not equal to null and fast dot next not equal to null. If the condition is true, what should I do? I have to move slow by 1 step and fast by 2 steps. Fast dot next. So I have got the middle element of my linked list. So in this I have completed my first part. Now I have to go for the second part. Reverse the second of the linked list. Now in this given linked list, if I find the middle element, how will it be? Let's discuss now. So this is slow and this is fast. So initially both are pointing to the same place. Slow will be moving 1 step. So slow will be here, whereas fast will be moved to this particular place. So condition is true. So what happens? Slow will be moved 1 step and fast will be moved 2 steps. Okay. Now condition becomes false. When the condition becomes false, slow will be pointing to the middle element of the linked list. Okay. So far I have written program for this. Now what I have to do? I have to reverse the second half of the linked list. Which means I have to reverse the second half. So this is the first half and after this we call it as second half. For that, what am I going to do is I am going to take one more object, link list to node second half is equal to, I am going to reverse. I am going to call a method called reverse and I am going to pass slow. Which means I am going to pass the address 3000 and I am going to reverse the second half. So when I reverse the second half, what happened? We'll see now. Let's discuss the reversal logic now. Here I have taken a linked list of size 5. Head contains the address of the first node. So here what should we do in the sense? The first node's address part I have to store null, and in the second node's address part I have to store the first node's address, and in the third node's address part I have to store the second node's address, and in the fourth node's address part I have to store the third node's address, and in the fifth node's address part I have to store the fourth node's address, and the fifth node address has to be taken and that has to be stored in the head so that we can reverse the linked list. This is the logic. So here I am going to take 3 objects. First object is to point to the current node's address. Okay, and 2 more objects I am going to take. One is going to point to the previous node's address and another one is going to point to the next node's address. Okay, so I'll just differentiate the colors. Okay, so here current node points to the first element of my linked list, and we don't know what is the previous node's address and we don't know what is the next node's address, so we'll initialize the value as null. We have to iterate the linked list until current reaches the end of the linked list. I'm going to take a while loop and I'm going to iterate until current reaches the last node of the linked list. If the condition is true, I'll go inside the loop. First step, what I'm going to do is I'm going to find the next node's address. How can I find the next node address? Current.next will give me the next node's address. So first step I'll be doing is I'll be finding the next node's address. So current is pointing to 1000. Current.next is 2000. So I have got my next node's address that will be stored in an object called next. Fine. After that, I have to change the address part of the current node. In the address part of the current node, I should store the previous node's address. So what I'm going to do is in the address part of the current node, so current.next, this is points to the address part of the current node. Here what should I do? I have to store the previous node's address. So initially previous node is pointing to null. So null will be stored in this particular memory location. Okay. Next, what am I going to do? I have to move previous by 1 step and current by 1 step. So here previous has to be moved to 1 step and current also has to be moved by 1 step. So wherever current is pointing, I have to point the previous, and wherever next is pointing, I have to point to the current over there. So for that, so previous equal to current. So wherever current is pointing, that should be pointed by previous, and wherever next is pointing, there current has to be pointed. That's all. So previous will be moved 1 step. Okay. Then current will be moved 1 more step. That's all. Now check the loop again. Current not equal to null? Yes, current is not equal to null. If current is not equal to null, what should I do? I have to find the next node's address. How can I find the next node address? Current.next is 3000. So next will be pointing to the memory location called 3000. And then in the current node's address part, what should I do? I have to store the previous node's address. Previous node's address is 1000. So 1000 has to be stored in the current node's address part. Okay. Done. Now this node is pointing to the previous node. Fine. Now previous has to be moved 1 step. Okay. Wherever current is pointing, that should be pointed by previous. Wherever next is pointing, that should be pointed by current. I have moved previous 1 step and current also 1 step. Now check the loop again. Current not equal to null? Yes, current is not equal to null. If current is not equal to null, what should we do? First, I have to find next node's address. Current dot next is 4000. So next has to be pointing to the memory location called 4000. Now what I am going to do? I have to take the previous node's address that should be stored in the current node's address part. So this is a current node address part. I have to store the previous node's address. So previous node's address is 2000. Okay. So this node is pointing to the previous node. Now what should I do? Previous has to be moved one step. Okay. And current also has to be moved by one step. Done. Next, what should I do? Check the loop again. Current not equal to null. Yes, current is pointing to 4000. That is not equal to null. What should I have to find the next node's address? Current dot next will give me the next node address. That is 5000. Okay. Then I have to store the previous node's address in the current node's address part. Previous node's address is 3000. That will be stored in the current node's address part. Okay. This second step also done. Now previous has to be moved one step. So wherever current is pointing, previous will be pointing there. Wherever next is pointing, current will be pointing over there. Okay. Now check the loop again. Current not equal to null. Yes, current is not equal to null because that is pointing to the memory location of 5000. So first what should do? Current dot next. So current dot next is null. So next will be pointing to the memory location called null. Okay. Next what should I do? I have to take the previous node's address, that is 4000. That should be stored in the current node's address part. Okay. I am done with it. Now previous has to be moved one step. Okay. It will go to the place where current is pointing, and current has to be moved by one step. It will go to the place where next is pointing. So both are pointing to null. Okay. Now what I have to do? I have to check the loop again. Current not equal to null. Condition becomes null because current is pointing to null. So I'll come out of the loop. After coming out of the loop, what should I do in the sense? I have to take the previous value that should be stored in head, because previous is the one which is pointing to the last node's address. I have to take that and that should be stored in head. So for our understanding, I'll take head and I'll place it here. Okay. So what should do? Previous is pointing to the memory location of 5000. That should be stored in head. Okay. Now let's traverse the linked list. Head will always contain the address of the first node, right? Okay. So head is pointing to the memory location called 5000. I'll go to that particular memory location. I'll take the data, that is 5. Then I'll go to next memory location 4000. I'll take the data 4. Then I'll go to the next memory location 3000. Okay. So I'll take the data 3. And then I'll go to the next memory location 2000. I'll take the data 2. And then I'll go to the next memory location 1000. I'll take the data 1 and I'll go to next memory location, that is null. It states that this is the last node of the linked list. That's all. After reversing, my linked list becomes like this. So we have two linked lists as of now. Let's assume this to be 1500. So first linked list 1 to 3000 and second linked list 1000. Sorry, here this will be 4000. 4000. This will be pointed to 1. Then it goes to 2 and it goes to 3, that is null. Now let's write the logic for reversal of the list. I have called a method here. Let's define the particular method. Public list node reverse list node head. So we have discussed the logic of reversal. As usual, we'll take 3 objects, which is for that we have to check one condition. If head is equal to null or head dot next is equal to null, what should I do? I have to return head. Else I have to take 3 objects, which is list node previous equal to null, current equal to head, and next is equal to null. Take a loop now. While current not equal to null. If current is not equal to null, what should I do? I have to find the next node's address. So next is equal to current dot next, and in the address part of the current node I have to store the previous node's address, and then I have to move previous by one step, current by one step. Done. Finally, what should I do? I have to give head is equal to previous, and then I have to return the head. I have reversed the second half of the linked list. After reversing the second half of the linked list, which means this linked list second half I have reversed. After reversing, wherever slow is pointing, in the address part of slow, I have to make it as null. So I'll make slow.next is equal to null. So here slow is pointing to 3000 and slow.next is null. Okay, we have made it as null. Now what I'm going to do, I have to go for the third part, which is compare both the list. Compare both the list. So to compare both the list, I have to take two objects. So first one, I'll take it as this, and second one, I'll keep it as here. So here I'll take current one. This I'll take it as current 2, because current 1 will be pointing to head and current 2 will be pointing to second half. So for that I have to write the code here, which means list node current 1 is equal to head, whereas current 2 will be pointing to second half. I am writing the code here, which means current 1 is pointing to the first node's head and current 2 is pointing to the second node's head. Okay, here what I'll be doing is I have to check the condition. So for that I have to take a loop saying that while current 2 not equal to null. You can take current 1 also not equal to null or current 2 also not equal to null. That is not a problem at all. Okay, so here because we are comparing both the linked list. Here what am I going to do? I have to compare the values. So which is if current 1 dot value not equal to current 2 dot value. If the condition is true, directly I'll return false, saying that it is not a palindrome. So here current 1 dot value is 1, current 2 dot value is also 1. Condition becomes false. If the condition is false, what should I do in the sense? I have to move current 1 by 1 step, current 2 by 1 step. Current 1 equal to current 1 dot next, whereas current 2 equal to current 2 dot next. So here current 1 will be moved by 1 step, whereas current 2 will also be moved by 1 step. Now check the condition. Current 2 not equal to null. Yes, current 2 is not equal to null. So current 1 not equal to, current 1 dot value not equal to current 2 dot value. Current 1 value is 2, current 2 value is also 2. Condition becomes false. So I have to move current by 1 step. So next address is 3000 and current 2 I will be moving to next 3000. Okay, check the condition. Current 2 not equal to null. Yes, current 2 is not equal to null. Okay, now current 1 dot value is 3 and current 2 dot value is also 3. So 3 not equal to 3, condition becomes false, which means current 1 has to move by 1 step. So I'll go to null. Current 1 is pointing to null now, and current 2 also to 1 step. That is also pointed by null. Okay, I'll come out of the loop. After coming out of the loop, what should I do? I have to return true, saying that it is a palindrome. Now let's write the remaining logic. So here I have to take a loop saying that while current 2 not equal to null. So what I'm going to do, if current 1 dot val not equal to current 2 dot val. If this condition is true, I have to return false. If the condition is not true, I have to move current 1 by 1 step and current 2 by 1 step. That's it. Finally, I'll return true, saying that it is a palindrome. Let's run the code now. As it passes the test cases, let's submit the code. It passes all the test cases. And here, there is one more logic people will be doing this. That is nothing but, I'll just write here. What they'll do is, they'll take all the elements of the list and they'll be storing it in stack. So what they'll do is, so they'll be taking a stack. In the stack, first they'll store 1, they'll store 2, then they'll store 2 and they'll store 1. And then they'll be traversing the linked list and they'll be taking one value from the list and they'll be comparing both. That is also one more logic, but this logic will take a time complexity of n and space complexity also n. Because you are storing all the elements in the stack. That is why the time complexity is also n and space complexity is also n. So taking all the elements in the stack, putting inside the stack, and then traversing the linked list, popping out the elements from the stack, comparing. If it is not equal, I'll say that it is not a palindrome. Finally, after the traversal got over, I'll be returning true saying that it is a palindrome. But in this logic, what we are doing is space complexity is big of 1 because we are not taking any extra space. Time complexity is n. Okay, that's all.